Hi, guys. Welcome back. Good morning, good afternoon, good evening, good night. I don't know when you're watching, but I'm glad you're watching. Today's section is 2.11 elements. Okay, so we're going to be talking about the periodic table, and we're going to be talking a lot about examples that we know of as far as elements, right? Common stuff. So let's get started. We are on packet page 74 and 76, 2.11 on our CK12 website. So here we are. Whenever it decides to load. Come on. All right, so here we are. We're starting 2.11, and we're starting by talking about Mr. Sherlock Holmes. All right, Sherlock Holmes. Who's going to read for me? I asked Julian yesterday. Sam. Sam, can you read this paragraph about Sherlock Holmes, and maybe we can figure out why he's at the top of our introduction? Well, our introduction. Go ahead, Sam.
The whole paragraph?
Yes, the
whole
paragraph.
paragraph?
Yes.
Okay. The famous fictional British detective Sherlock Holmes was often said to make the statement, "Elementary, my dear Watson." In reality, the closest he ever came to that line was an exchange with Watson in a short story, The Crooked Man. Holmes shows, what does that say?
Shrewd.
I can't really use that.
Shrewd.
Shrewd insight into Watson's activities of the day. When asked how he knew what Watson was doing, Holmes simply replies elementary. Regardless of exactly how he put it, Sherlock was simply referring to what the Free Dictionary defines as relating to or constituting the basic, essential, or fundamental part.
Thank you, Sam. That was excellent reading. All right. So, if you've ever heard of Sherlock Holmes was a private eye. He's a fictional character written by a great author, Sir Arthur Cohen or something like that. But I know because I read a bunch of his books, and one of his most famous lines that everybody knows is that he supposedly said, it's all elementary, my dear Watson. And what that means is he would look at the most basic hints, clues that people normally overlook. And he used deductive reasoning to figure out, okay, well, what were you doing? In the case of Watson, well, maybe Watson kind of smelled like his girlfriend. So what? So Sherlock would have known, hey, you were with your girlfriend. I know, I can smell her. Or if maybe he was having a cigar before going to meet with Watson, hey, I know that you were hanging out with such and such person because that's the type of cigars that he smokes, and I could tell from the odor. Also, if Watson was somewhere where it was raining, Sherlock would notice, hey, I know you were here and here or there because there's that type of dirt and it's on your boots. That was the type of person that he would look at the most basic clues and hints and do deductive reasoning and figure out where you were. So I think that the reason why they're bringing him up is because if you think about the word elementary is, like they said, the definition, constituting the basic, essential, or fundamental parts. So today we're going to talk about the basic fundamental parts of substances, and they are elements, okay? In the case of an element is the simplest form of matter that has a unique set of properties. So everything that's on Earth is made up of different elements, okay? And elements is the smallest form of matter that we know of, okay? We know that atoms do exist and they do make up elements, but as far as the identity of that substance, the most simplest would be the element, okay? And elements have their own properties. Some are very reactive, some are less reactive, some are not reactive at all. They don't bond with anybody. They're like the noble gases. But if you have a halogen or an alkali metal, those react very, very quickly and very, very violently. Okay. Some elements are worth more than others. Obviously, gold is, very high in value. Other elements, maybe like cobalt, might be not as, or zinc might not be worth as much. Okay. That is just because it has a unique set of properties. All right. Elements are considered pure substances. They cannot be broken down into a different type of substance. Okay. Once you have an element, that's what it is. You cannot switch it and change it into another type of element. As of 2010, there are 118 known elements on our periodic table. 98 of those elements, 98 occur naturally on Earth. 20 of those elements are man-made. They're synthetically made in the lab, okay? They have to be created in a laboratory setting or they do not exist at all, okay? Every element on can be found in one place, right? We all know the periodic table. Here you can see is a picture of a periodic table with all 118. So you got to think about it. When this periodic table was first published, there was maybe 30 elements on here. And then you look 100 years later and there's 118. So you can imagine what this periodic table is going to look like in the next 100 years, right? Maybe there'll be twice as many elements. We don't know. We don't know the possibilities, but they are infinite. Here are some examples of some well-known elements: iron, oxygen, and gold. Okay. Remember, elements cannot be broken down into simpler substances. That is as simple as you can go. One element cannot be converted chemically to a different element. All right. So here you have some. What about the ones in the bottom row? Oh, these are already counted. If you can tell, Gael, LA to LU technically is supposed to be in between. You see this block right here? They're supposed to be in between here. Instead of it being so small, it's supposed to be like super long. So what they do to condense the periodic table, they take those two rows and they put it down. So as you can see, lanthanide all the way to lutetium actually is supposed to be between barium and hafnium. If you have actinide, actinide is supposed to come after radium. And lawrencium, LR, is supposed to come before ruthenium. All right, so that just, they're supposed to actually fit and the periodic table gets super long. So instead of it being super long, they've removed those two groups or families and they've put them at the bottom, okay? Good, good, good. Some of them are brighter, yes. Are they rare? Some of them are very rare. Uranium is one of those fossil fuels that you have to pull from the earth. Plutonium, I think, is on here also. Yeah, plutonium. Very, very good. Some of them are very rare. Some of them, they're more common. So, like I was saying, if you've ever had a panic attack when those paramedics got there because your mom started freaking out, the first thing they're going to do is tell you to breathe oxygen, right? The second example they give you here is an iron skillet. Iron skillets, they're great. They're really durable. They can last for forever. And they're safe that you can even put them in an oven with your very delicious dish that you're baking. Gold, oh, we can only dream about owning a couple kilograms of gold, right? Some elements have been known for centuries. They've been around for hundreds and hundreds of years. For example, gold, silver, copper. All of that has been used for centuries to pay, right? If I needed, if I needed whatever supplies, food, I would pay in gold, silver, and copper. Iron has definitely been a part of the human, has been part of wars, right? Anytime that there was a war, somebody had an iron weapon, whether it be a sword or a bat or a stick. I don't know. You guys are history buffs. You guys are taking history. You tell me. Um, while other elements have just been created in the lab with only within the last several years, most elements do not exist as such in nature. So, what do we mean by that? They are so reactive that they can only be found combined with other minerals. One of those that I always think of is like phosphorus. Phosphorus is always found um, chemically bonded to other elements because it's so reactive. It automatically will start to burn as soon as it gets exposed to certain materials and certain gases in the air. So you won't really find phosphorus by itself. You might find it bonded to some other elements. It's very reactive, so it will bond easily with other elements. Several of these elements are considered very valuable. Tin, thank you. Some are very valuable and some are quite inexpensive. Look at that. If you had a little nugget, a little ounce of gold, that little ounce of gold would be worth $1,700. Imagine that. Imagine if you had a brick. Imagine if you had one of these bricks. How much that brick, 1 kilogram, would be worth. Hundreds of thousands of dollars, I'm sure. Imagine if you just had those three. I would totally settle for just those three. Another type of metal that is very inexpensive is aluminum. How many of us, when we were small kids, collected aluminum cans because you thought you were gonna make a lot of money? Anybody? Anybody here? Gael, you definitely collected cans when you were young. Do you remember how much you made? Like the most, Was it a big number? Right, Sam? You like turned in like 10 bags of aluminums, right? Of aluminum cans. And all you got was like $5. And you're like, I'm never doing this again, right? It's more trouble
Or
than
$10.
Yeah, right? For $10. That's all you get. And you're like, but it took me months to collect all these cans. Why? Because aluminum is not a very valuable metal. It's about 90 cents per pound. That's a lot of aluminum for just 90 cents. Excuse me, guys. Sorry. Copper is a little bit more valuable. It sells for approximately $3.50 for every pound. Anytime that a building is being constructed, you'll probably see storage units that are locked up that have that copper because there are people who go into construction sites and steal copper just so that they can resell it. Platinum. I did not know how valuable platinum is. Platinum is almost the same value as gold. Check that out. 1,650 per ounce. Did you ever think that
just for $50, man, it's like the difference?
I know. Imagine, dude, I'm gonna look for some platinum somewhere. I don't know. But yeah, it's almost the same value. Isn't that crazy? I would have never thought platinum would be that valuable.
Just steal from the bumpers from the trucks and they have the platinum grill.
I don't think it's the same kind of platinum. It's probably like an isotope of platinum. I don't know. We'll see. All right. So we already talked about the simulation. You always have to remember that the air around you, and I'm just going to go through it real quick. We're just going to talk about a couple elements because we've already seen the simulation. This is already the third time. But today, instead of talking about molecules, we're going to talk about atoms. So in the air around you right now, you have elements like helium, the second most common gas in the universe. Neon gas is definitely floating around, what you see in storefront lights. Argon. Argon is considered a lazy gas. Why? Because it doesn't like to bond with anything. Okay. It's also found in Mars's atmosphere. Krypton. Krypton is not only Superman's home planet, it is also one of the rarest gases on Earth. So if you ever find some krypton, save it. Right? It's a gas. How can we save it? Xenon. Xenon is considered xenon means foreign or stranger. It is the first noble gas to form compounds. Did you ever know that? Noble gases, as far as we know, they don't like to bond with anybody, right? Because they already have 8 electrons. Well, xenon is one of those weird guys. You know how you have that weird cousin? Well, xenon is that weird cousin that you never thought would get a girlfriend, but ends up getting a girlfriend. All right. So that's just a little bit about some of the atoms that are in our atmosphere right now. So this is the song that I was telling you about. It's an older song. It only includes 102 elements. So even like maybe this video is maybe what, like 20, 30 years old. So 20 or 30 years ago, there was only 102. Now we have 118. Look at the discoveries we did in just that short amount.
I just imagine how it's going to be like in the next 50 years, probably like around 200 elements.
Exactly. Doesn't that blow your mind? Like, who knows what they can be discovering in the next 50 years? Just like you said, there might be 200 elements. We don't know. We're going to have to wait and see if I'm still around. I'm hoping I'll still be around. You guys will definitely be around.
Antimony, arsenic, aluminum, selenium, and hydrogen and oxygen and nitrogen and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, and radium, and gold, protactinium, and indium, and gallium, and iodine, and thorium, and thulium, and thallium. There's yttrium, ytterbium, actinium, rubidium, and boron, gadolinium, niobium, iridium, and strontium, and silicon, and silver, and samarium, and bismuth, bromine, lithium, beryllium, and barium. There's holmium and helium and hafnium and erbium and phosphorus and francium and fluorine and terbium and manganese and mercury, molybdenum, magnesium, dysprosium and scandium and cerium and cesium and lead, praseodymium and platinum, plutonium, palladium, promethium, potassium, polonium and tantalum, technetium, titanium, tellurium and cadmium and calcium and chromium and curium. There's sulfur, californium, and fermium, berkelium, and also mendelevium, einsteinium, nobelium, and argon, krypton, neon, radon, xenon, zinc, and rhodium, and chlorine, carbon, cobalt, copper, tungsten, tin, and sodium. These are the only ones of which the news has come to Harvard. And there may be many others, but they haven't been discovered.
All right. So that was just a quick song of 102 elements on our periodic table. All right, so let's summarize. Let's close out today. An element is the simplest form of matter. You have to always remember that each element will have its own set of properties. One element cannot be chemically converted into another element. So you got these 4 review questions to do. They're really easy. Get them done. I'm going to give you a little bit of time. Let me stop the